Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Bread and Butter by Sudoku, and here are the rules. We have normal Sudoku rules apply, that is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. We have entropic lines, where any 3 adjacent digits along a peach line must contain one low digit, 1, 2, or 3, one medium digit, 4, 5, or 6, and one high digit, which is 7, 8, and 9. So as an example, along this entropic line, we could have something like, say, 5, 8, and 1 here. This would be valid to satisfy the part of the rule for the entropic line, because these 3 adjacent digits contain one low digit, 1, one medium digit, 5, and one high digit, 8. So that's an example of how entropic lines work. We also have killer cages, where digits in a cage must sum to the clue in the top left corner. So for example, if this were, say, a 7, this would have to be a 2, because these 2 digits must add up to 9, which is the digit in the top left corner of the cage. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what I like doing for particularly entropic lines is start by coloring the sets. And this works for any line which has essentially three distinct sets and repeats has the criteria of 3 adjacent digits having to be from different sets. So we're going to start this, I guess we'll do blue, orange, and pink here. And then this is blue, because we already have one from the orange and one from the pink set in this set of 3, so this must be blue. So every third digit on one of these lines will always be the same set, right? Because you have to have 3 distinct, for 3 adjacent digits, you must have one from each distinct set. And it's going to be, so since you have orange and pink here, this must be blue. Since you have pink and blue here, this must be orange, right? So you'll have every third set be the same one. So then this is pink. Now this must be blue. 1, 2, 3. So that's blue. 1, 2, 3. So that's blue. So then we have blue here. This must be orange. 1, 2, 3. 1, 2, 3. So this is orange. And these are pink. Now, what this tells us is the distinction of what we have in each row, potentially. So we can also do it this way. So I'm going to do red, yellow, and green here. So red, yellow, green. So this is red, 1, 2, 3. 1, 2, 3. 1, 2, 3. So these are red. These are yellow. And these must be green. So notice I did not color them the same as this because they could be different sets here. And now we're probably going to be trying to figure out what the numbers could be. So this is 2 unique digits adding up to 14. So it's 5, 9, 6, 8. This is 2 unique digits adding up to 15, so it's 6, 9, 7, or 8. 2 unique digits adding up to 5, 1, 4, 2, 3. 2 unique digits adding up to 6, 1, 5, 2, 4. 2 unique digits adding up to 15, again, 6, 7, 8, 9. Interesting. What does that tell us? I'm not sure. We have to have a 1 somewhere here. We know we have 3 orange digits in row 2. That's probably the most limiting factor here. So let's figure out what this cage can be. It could be 3, 9. It could be 5, 7, or 4, 8. So this is guaranteed to be, you have guaranteed one of these is 0 mod 3. Or no, sorry, high digits and low digits. We're high digits and low digits. Okay, so this is guaranteed to be 1 low digit and 1 medium digit. We have high and low. Interesting. So this is guaranteed to be 1 low and 1 medium. Okay, so I should probably not use these colors, but whatever. Because I like using red, green, and blue for high, medium, and low. But so this is guaranteed to be 1 low, 1 medium. This is guaranteed to have 1 high. So the question in this then, so that means in this box, whichever one has 2 of the digits can be the low, right? So green can be low, red can be low, because we're guaranteed only 1 low digit in this box. Yellow then has to be medium or high. So yellow's medium or high here. Here, we're guaranteed... Here, we're guaranteed 1 low. And possibly a second low. Or a third low? It could be... It cannot... Okay, so cannot be all 3 lows here. So that means we're guaranteed... I think it has to be... It could be 4, 6 here, but if this is 4, 6, this would force this to be 2, 3. So we're guaranteed to have 2 lows in this lower left-hand box. Because if this is 1, 4, then this must be 2, 8 or 3, 7, which is guaranteeing a low here and a low here. If this is not 1, 4, it's 2, 3, which is guaranteed 2 and 3 must be low, so that's at least 2 lows. So that means greens have to be the low. Okay, so then we're going to make this essentially dark. So greens are the low here. So greens are low. That's low. We have to have... So if this is 4, 6, this would force this to be 2, 3. But then 4 and 6 are both mediums. And we have both lows and both mediums here, which is not allowed. So we're guaranteed to have... This cannot be 4 and 6. This must be 1, 2, 3 with 7, 8, 9. And again, this cannot be 2 and 3 because that would force us to be 1, 9. And then this entropic line would not work. So this has to be 1, 4. And this must be 1, 9. And the reason is because if we had 2, 3 here, this would force us to be 1, 9. And we would have all 3 lows already accounted for in this box, which obviously the entropic line would not work. Okay, so that's there. We don't know if yellow is high or red is high here. So this must be 1, 2, or 3. 1, 2, or 3. This is... Okay, so we have guaranteed low in one of these two. This is low, and this is low. We have 3 guaranteed lows in row 7, which means this cannot be low. So this is 7, 8, which makes this 2, 3. We now have 3 guaranteed lows in row 8. So this cannot be low here, so this must be 4 and 1. So this is low. This is low. We know we cannot have a low in row 8 or row 7 anymore, so this must be a low here. So, we have red and yellow 2 reds and 2 yellows in row 9, which means this has to be one of each here. So this must be 6 and 9 here. So one of these is mid, one of these is high, one of these is mid. That means this digit must be mid. So yellow has to be green, and then red is actually high. So this cannot be 6, 7, 8, 9. This is 4 or 5. And then this is 7 or 8. This is 7 or 8. So this must be 4, 5, 6. It can't be 6. This is 4 or 5. This can't be 4 or 6. So this must be 5 here, which forces this to be 4. 4 eliminates 4 here, so this is 5. This is mid. We have... One of these is mid, one of these is high. So this is 2, which could be with 6, or 3, which could be 5, because it can't be 1. So this must be mid here. So this is the remaining mid. This is 6 then. Can't be 4 or 5. So this must be 6 and 2 to add up to 8. Which means this cannot be 6 and 9. This has to be 7 and 8 as 2 high digits. Okay. This is 2 and 3. We have a 2, 3, 2, 3 pair in row 8, which eliminates 2 and 3 in the rest of the rows. So this cannot be 2 or 3. It's 1. So this cannot be, it could be 1, 5 anyways. So this is 2, 4 as a pair, which eliminates 1 and 2 here. So this must be 3. That leaves this as a 1 and this as a 3. Okay. So orange, I think, that's not true. We know this is 1 mid and 1 high. This has to be another high in this 12 cage, because it's 3, 4, 5 with 7, 8, and 9. So that means we have guaranteed 2 highs in this box. So whichever there's a color that's only 1 of a color must be the high digits, and that must be orange. So we have, because 1 orange in this upper central box, so this must be, it must match to high. We have 3 highs in row 2, so this cannot be high. This is mid. And 5 and 6. This can't be high, so this must be 3, 4, 5 here. Well, we know this is mid. We have 2 of each of the other colors. That means since this is mid, this cannot be mid here. So this must be low. And it must then be 3 and 9, which eliminates 9 in the rest of the box. So this is 8 and 6. So this is high. And this is high. 8 eliminates 8 here. So this is 7. Which means this can't be 7. That's 8. Which means this can't be 8. So it's 7. Which makes this 8 and 2 to add up to 10. That makes this 3. This is 9. So this is 6 here as the last mid. 8 eliminates 8 here, so it's 7 and 8. That leaves this as 9, and this is 5. Okay. We have 2 highs here in this upper left-hand box. That means one of these has to be 2 mids, because only one of these can have 1 high. That would be 2, 3, 4 with the 7, 8, 9. And then to not have 7, 8, 9 but still add up to 11, it must be 5 and 6. So one of these is a 5, 6 pair, which means one of these is 2 mids. Well, that means we have 2 mids. It can only have one other color to match it in the box. So this is the only one with 1. So this must be mid, which means pink has to be low. So This 6 eliminates 6 here, so this is 9 and 6. Therefore, this is high. This is medium. Well, we have 3 highs in column 4. So this cannot be high in either of these cells, so therefore this must be high to satisfy the entropic line, and one of these is low, one of these is middle. Since one of these is middle, we have 2 middles here. That's 3 middles in the rest of column 4, so this can't be middle, it's low. So this is 1 or 2, which means it's with 7 or 8 to add up to 9. So this is high guaranteed, which means we have 3 highs in column 3. So this could be low or medium here. It cannot be high. So it could be low, so it could be 2, 9. Cannot be 3, 8 because of an 8 in the row. Or it could be 5 and 6. So this is 2, 5, or 6, 9. We have 3 highs in column 7, which eliminates highs in the rest of the column. So one of these must be high here. This is low or medium. We don't know which. And one of these is high. So therefore, this cannot be high here. It also can't be low because we have 3 lows in column 6. So this can't be low. Therefore, this must be low here. And this must be a high medium pair. This can't be low anymore. So this has to be medium, which makes this low. So this is 4. This is 2. This can't be 2 or 3 because 2 in the column and 3 in the box. So this is 1. That leaves this as 2. So this can't be 2 and 9. This is 5 and 6. So these are both the mediums, which makes this a low-high pair. It cannot be 2, 9 because of 9 in the row. And obviously can't be 4, 7 because it doesn't have a low. So this must be 3 and 8. 8 can't be here because of 8 in the column. So this is a 3, which makes this 8. So again, this is low. We have high here. We have 3 highs in row 3, which means this cannot be high. So no 7, 1, no 3, 5. This has to be 2 and 6. We don't know which is which. This can't be 2 or 3 because of 2 in the row and 3 in the column. So this is 1, which makes this 2. This can't be 5 or 6, so this is 4. This can't be 8 or 9, so it's 7, which makes this 9. 7 eliminates 7 here. So this is 8 and 1 to add up to 9. That makes one of these 2. We have a high and a middle here, so this must be middle here. So this is not 4, it's 5 or 6. 5 would add up with 4 to add up to 9, so this cannot be 5 because this is a 4 here. So this is 6 and 3, which makes this low. That leaves this as a 5, 7 pair in column 6. This can't be 5 because, or 6 because of 5, 6 in the row, so this is 4. To add up to 10, we cannot have 1, 9, 2, 8, or 4, 6, so this must be 3, 7. 3 can't be here because 3 in the column, so this is 7, that's 3. Therefore, this is high, this is low. We celebrate the 3 in the corner. This cannot be 2 or 3, so this must be 1. This is 9 because we have the remaining digits. This can't be 8 or 9. It's 7, which makes this 8. This can't be 4 or 6, so it's 5, which makes this 4. And that leaves this as a 5 here. Okay, remaining digits in column 3. This is low, and it must be 3. This is high, and must be 9. So now we're just doing normal Sudoku, essentially. Well, yeah, this is 2 or 4. Remaining digits in column 7 are 1, 2, and 6. This cannot be 1, it cannot be 3, this must be 2. So that makes a 6, which makes that 2. So this is medium, and this is low. That leaves this as a low and is 1. Yep, we just got to do normal Sudoku. Okay, so we have 8 1s. We know where the last one has to be. It has to be here. 2s are probably not going to be as restrictive. Oh, they are. In this left central box, 2 cannot be here or here, so 2 has to be here, which makes this 4, which makes that 2. So this is not low, this is medium, which forces this to be low. Obviously, these are low. So we should have all the 2s now. And then 3s, we have 8 3s. We know where the last 3 has to be. It has to be there. 4s, we have 7 4s. Ooh, that's not going to be that helpful. 5s, we have 6 5s. 6s, we have 7 6s. 7s are gonna not that restrictive either. We have 6 7s filled. 8 is not that restrictive. And 9s are probably gonna help us. So in the central box, 9 cannot be here and cannot be here. These are filled out, so 9 has to be here. We have 8 9s. We know where the last 9 has to be. It has to be there. Okay. So does that help us with anything? I'm not really sure. Maybe. We have remaining digits in column 9 are 5 and 7. We have a 5-7 pair in row 5. So that leaves us 6 and 8 remaining. This can't be 8 because of 8 in the column. So this is 6, this is 8. And that should help us. We do. We have 8 8s, so we know where the last 8 has to be. It has to be here. 6s, we have 8 6s. We know where the last 6 has to be. It has to be here. That leaves this digit as a 4. This digit has to be 5 or 7. It cannot be 7 because of 7 in the column. So this is 5. This is 7. That's 5. 7, 5. This is high. This is not high. That's medium. That leaves this digit as a 4. Oh, which is green. And this must be 7. And that's a solution. Yeah, fairly straightforward, I guess. Interesting dynamics. At first I thought this was a modulo line, so I was running into little problems there, but quickly figured it out. It had to be entropic lines, right? I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.